This question gives us the opportunity to practice some of the principles that we've talked about, as well as the idea that a local minimum on my original graph will give us a local maximum on my reciprocal graph and vice versa. So here we have a graph of x squared plus 2. Now that's a parabola that's been translated up by 2, and therefore it has an intercept at 0, 2. My reciprocal graph, which I'll draw in red, therefore we're going to draw on the idea that as my original graph approaches infinity, we've talked about this before, so as n approaches infinity, 1 over n approaches 0. So therefore, as my dark blue line gets larger and larger, my reciprocal line gets closer to 0. Then as it gets smaller, you can see my reciprocal line will get larger because as n approaches 0, 1 over n approaches infinity. We also know that when n equals 1 or n equals negative 1, 1 over n will equal either 1 or negative 1, depending on which one. So here we know we've got a local minimum at 2, which means I know my red graph is going to have a local maximum at 1 over 2, which is a half. So ultimately it's going to look like, let's try and make it a bit better than that. It's going to look like this, where there's the maximum and then it comes back down. So that's the graph of the reciprocal of this parabola. See, I've just tidied it up a little bit so it's smooth and it should be symmetrical on both sides of the y-axis.
If you found this video helpful, please subscribe to my channel or like the video.